Hi everyone. So in this video, we're going to go over expanding, condensing, and how to solve logs. Should be pretty straightforward. There's like these four main rules and properties that we're going to go over at the beginning that'll really help. And yeah, hopefully it's quick. Okay, so the first property is going to be the product property. So if you are multiplying two things inside your argument, you can rewrite them using addition. So that just becomes log base A of m plus log base A of n. Okay. Next one, the quotient, is if you're dividing two things in your argument, you're just going to rewrite them using subtraction. Okay, so if you think the division bar kind of looks like subtraction, so that's how you can remember that one. So you'll have log base A of m minus log base A of n. Right, the next one is for powers. So if you have an exponent, all you're going to do is you're going to bring that down to the front. Okay, so that becomes n times log base A of m. And the last one, we kind of touched on this in the last video, ish. It'll make a little more sense now. But this one, if you have a root, you can rewrite your root, right, as an exponent. Okay, so the way you rewrite this would be m to the 1 over n, and then all we do is we just use our power property and bring that 1 over n to the front. So we have 1 over n times log base A of m. Okay, so those are our four main properties that we're going to go through today on how to expand and condense logs, and then they're also going to be really helpful when we have to solve logs as well. All right, so for number one, we see that we're multiplying two things, so we're going to break them up using addition, and this will become log base 6 of 3 plus log base 6 of x. Okay. Number two, we haven't talked about this yet. This ln, that's called the natural log. Okay. We're going to get into that in a third video. It's just another form of a log with a different base. Because remember, our common log has a base of 10. And this is just another log that has a different base, which we will get to in the next video. Okay. So since we are dividing these two, we're going to just split them up using subtraction, right? So this becomes ln of x minus ln of y. All right, number three, we see we have an exponent, so we can use our power property and bring that to the front. So we have 5 times log base 3 of x. Okay. Number four is our root property. So we can rewrite this fourth root as x to the 1/4. And then bringing it down in front, we have 1/4 times the natural log of x. Okay. And then we see this one has a few parts to it, right? So this has a root. We can write that as x to the 1/2, and then we're still multiplying. So we'll have log base 4 plus log base 4 of x to the 1/2. You remember what we can do with this little bit right here, since our base and our argument are the same. This is just going to become 1 plus, and then we have our exponent, so we have to bring that down. 1/2 log base 4 of x. Okay. Number 6, this is tricky. So on the inside, we're not multiplying anything, right? So we can't split it up with addition. We're not dividing. We can't use subtraction. This is actually already expanded as much as it can be. Okay, if this was x times y, then we can split it up. But since you're adding the argument, there's no little trick for how to do that one. Okay, so make sure to be careful of that. All right, number 7, we're multiplying and we have an exponent. Okay, so this becomes log base 8 of x plus log base 8 of y squared. We still have to keep going. You can do all this in one step if you want. It's really just your preference. For this video's purpose, I'm just going to go step by step so you guys can see where I'm getting everything. So then the next step, we still have to move this squared. So it becomes log base 8 of x plus 2 log base 8 of y. Okay. All right, number 8. Okay. we are dividing, right? So we're going to use subtraction. Okay, so we'll have log base 5 of x to the 8th minus log base 5 of y cubed. And now we have our exponents that we still need to bring down. This is going to become 8 log base 5 of x minus 3 log base 5 of y. Okay, but these, once you get the hang of them, they're pretty straightforward. As long as you remember all those rules from earlier, you're good to go. Okay, so this one, we have our root. This becomes x to the 1/2, right? So now we can rewrite natural log of x to the 1/2 minus the natural log of y. Still need to move our exponent down on the natural log of x. This becomes 1/2 natural log of x minus the natural log of y. Okay. Last one, this one's a little lengthy, okay, since we have our entire cube root. So we can write we can rewrite this first as log base p of m to the 5th, n to the 4th over t squared, all of that to the 1/3. Okay, so I would do it like this personally. I think it just looks a little neater. So we bring the 1/3 in front, so we'll have 1/3 log base p of this whole thing, m to the 5th, n to the 4th, t squared. Okay, so now we can break it up, right? And then we'll just keep the 1/3 out front. Okay, I feel this be a little bigger. Keep the 1/3 out front, and then just write it for each of the little terms. So we'd have log base p of m to the 5th plus log base p of n to the 4th minus log base p of t squared. Okay, we can keep breaking that up because if we have all of our exponents we still need to bring down. Just keep our 1/3 out front. Okay, so we have 5 log base p of m plus 4 log base p of n, and then minus 2 log base p of t. Okay. So, yep, that's it on expanding. Okay, now we're going to work on condensing them. So just kind of undoing everything that we did, right? So for number 1, we see that we're subtracting these 2 logs. Okay, so that means we're going to need to divide. So this will be log base 3 of 7 over x. Okay, the most important thing, and I should have said this earlier, when you're condensing and expanding, you have to have the same base, right? So since both of these are base 3, you can combine them. But say, for example, that was one of them was log base 4, then you couldn't combine them. Okay, your base has to be the exact same to combine them. Okay, number 2, we're adding. So that's going to be multiplication, and we have a number up front. So we're going to have to make that an exponent, right? So first we can just move our exponent. So it's going to be log base 5 of x squared plus log base 5 of 3. Now we can combine them and multiply to become log base 5 of 3x squared. Okay, I like to put it in parentheses. I think it just looks a little nicer, especially when you have like a bunch of terms. But you don't technically have to. It's just kind of like math grammar stuff. But yeah, so I like to put all of it in parentheses just so I know exactly what I'm taking the log of. All right, number 3, all addition. So we're just going to multiply all of these together, right? This becomes log base 4 of 5 times x times y. And that's it. Number 4, we have an exponent we need to move. And we're subtracting, so it's going to be division. This will become log x to the 1/2 is just the square root of x divided by 4. Okay. Number 5, we have an exponent we need to move. And we have another exponent we need to move. So this will become y squared to the 3rd. You guys remember your exponent rules? You're going to multiply these since you have a power to a power. This becomes y to the 6th. So now we can rewrite this since it's division. We're going to divide. We're going to have log base 2 of the cube root of x squared Or you can write that as x to the 2/3, doesn't matter, divided by y to the 6. Number 6, what you're going to do is you can read it, you can condense it first. You have 6 times log a times b, right? Then you can move this as an exponent. I would do it as log base 10 of a times b to the 6, and then you can distribute that exponent in. So your final answer would be log base 10 of a to the 6 times b to the 6. It gets a little like confusing when you have like a common exponent like that. It doesn't really matter which way you write it. You can leave it as this or this. I will accept either. They do mean the exact same. You would never be given like a quiz or something that would have both of these as options, like a multiple choice question that you'd have to pick from. So I would give you credit for both. Truly, it does not matter. All right, so now what we're going to go through is we're going to go through the 3 different types of equations that you'll have to solve. Okay, so this first type is when we have logs on both sides. And so these are our steps that we're going to follow right here. So the first one is we need to condense. Okay, so we just want it to have everything needs to be cleaned up as best as we can. So we need to move this 2/3 as an exponent, right? So this will become log base 7 of x equals log base 7 of the cube root of 8 squared. Okay, next step, eliminate the log part. Since these are both log base 7, we can just cross them out. Okay, so it becomes x equals, the cube root of 8 is 2, so 2 squared, and then x equals 4. Okay, number 2, again, first we need to, first, this is a typo. That should be log base 3. I think it might be fixed in the copy I posted for you guys. I don't really remember. If not, my bad. That's just log base 3. So now what we need to do is we need to condense. So we need to move this 2. So this will become log base 3 of 2x equals log base 3 of 4 squared. Again, we can just cross off our logs since they're the exact same on both sides. That leaves us with 2x equals 16. Divide by 2 on both sides, x equals 8. These are straightforward. It's just a matter of getting yourself into a position where you can then just like algebraically solve it and you kind of get rid of the logs. Then you're good to go. So it's just really important to know your the properties that we went through at the beginning of this. All right, so next type is when there's a log only on one side of the equation. So first thing, it's actually not written. You want to isolate the log. Okay. So if you have, let's see, there's an example number 4. So that'll be the first step of number 4. We'll get there in a second. So for number 3, our log's already by itself, right? So now we can loop around. We're going to write it in exponential form. So this will be 2 cubed equals 2x. We know 2 cubed is 8. So 8 equals 2x. Divided by 2 on both sides. X equals 4. Okay. Number 4, so we need to isolate. We need to move this 1, so we're going to subtract 1 from both sides. And so we have log base 16 of x equals negative 1/2. Right, now we can write in exponential form. 16 to the negative 1/2 equals x. So this one we can rewrite as 1 over 16 to the 1/2 equals x. To the 1/2 is just the square root, and the square root of 16 is 4, so 1/4 equals x. Okay. Last type is when there are no logs, okay, and you just have exponents. So there's 2 ways of doing this. Okay, so there's method 1, and then there's a method 2. So these problems are going to be done with method 1. I'm just going to kind of split the paper in half, right? And so we'll have method 1 and method 2, and then examples for each of them. Okay. So, first method, you're gonna take the log of both sides. Okay, so literally you're just gonna slap a log on both sides. So this becomes log 5 to the x equals log 14. Because what you do to one side, you need to do to the other. Okay, since we have our exponent right here, we need to bring that down. So x log 5 equals log 14. Okay, we want x by itself, so we just divide both sides by log 5. So we have x equals log 14 divided by log 5. And that's that. Number 5, same thing, log on both sides. So log 2 to the x equals log of 7. We need to bring our exponent down. So we have x times log 2 equals log 7. Okay, x equals log 7 divided by log 2. Okay, and some people may be tempted to try and condense this into like log of 7 over 2. Not how that works. Okay, that does not mean the same thing as log 7 divided by log 2. All right, the second method is using the change of base formula, which is right here. Okay, I personally like this method a lot more. Yeah, I don't know. I just like to think of this as I don't know. I think this is just a lot more straightforward. Or the second method, you can just kind of like loop around, right? So the opposite of our loop, which is what we had done previously. So if we loop, right, we get log base 5 of 14 equals x, right? And so then change of base, if we wanted to, we can write it as using the change of base formula that's right there. Log 14 over log 5 equals x. And that gave us the exact same answer that we had using the first method. Okay. Doesn't matter which way you write it. I will accept both of these. Okay. Both are right. They mean the same thing. Yeah, I don't know. I personally like using the second method of just doing our loop more. I think it's just a lot more concise and just easier. But the first method where you take the log of both sides, that's the more like theoretical understanding of logs and how they work and that sort of thing. So yeah, number 6, the last example we're going to go through, we're going to just loop. So we have log base 11 of 8 equals x. And that's it on expanding, condensing, and solving logs. If you have any questions, email me. Use the distance learning Google form if you have questions on like the homework, classwork, whatever I post. And yeah, feel free to ask them also in office hours or during our live class sessions.